Okay, so the thing is that most health studies they compare the outcomes at different levels of exposure. For example, you might be interested in knowing if coronary heart disease incidence occurs more among smokers or in non-smokers, or male or female, or we might like to know if, say, the incidence of cerebrovascular accidents is more among those with higher cholesterol versus those who have normal cholesterol. But the issue is that all those results are based on a small sample, but not entire population. We might have, say, 300 individuals or 400 individuals, or maybe a few thousand individuals. In case of Framingham Heart Study, we had 5,209 individuals, which is a big sample, but still it's not the entire population, not even the population of Framingham Town. Now, the issue is that these samples can vary from one to the other. For example, we saw previously that the diastolic blood pressure was 2 millimeters of mercury higher among males versus females in the original sample of 5,209 individuals. But if we take another sample, we might not even see that much of a difference, right? And if we take another sample, a third sample, that time we might see a difference of even the difference might be even bigger, maybe 4 millimeters of mercury. So there is a natural variability that can occur from sample to sample, and we need to know if our results of 2 millimeters of mercury that we saw in Framingham Heart study original cohort is true or not. So how do we address that? That's where the concept of statistical significance comes into play. We try to estimate the whole range of values in which the true population difference might fall. The confidence interval term comes from there. It is normally 95% that we used in health research. That tries to estimate the range of the true population difference based on the sample data. P-value is a complementary value of a confidence interval. It quantifies the probability that the difference that we saw based on our sample is not just by chance. Um, Sorry, let me take a step back. It quantifies the probability that the observed results occurred just by chance. And if uh, the value is 5%, if that means that if the probability of getting that much of a difference is less than 5%, we accept that this is a true difference. So the thing is that if the entire confidence interval does not include zero, then we conclude that there is a true difference the between the different levels of exposure when it comes to the occurrence of outcomes. And if the p-value is less than 0.5, we consider that the tests are statistically significant. So what are we going to learn in this chapter? First, we will try to distinguish between population and sample with some examples. Next, we'll talk about the normal distribution and the concept that we use to estimate the range of confidence interval, and also the p-values. Then we'll discuss the empirical rule, the 68, 95, 99.7% rule. We will try to understand what central limit theorem is, and then we'll get into this a very important concept of famous infamous confidence interval. We'll try to understand the value, the probability value, the p-value, and finally we'll talk very briefly about the hypothesis testing.